Uh, in your blog, I also came across this hierarchy of study
Hmm.
design. One thing that was really surprising to me was, the meta-analysis is at the top of the pyramid and
Hmm.
RCTs is in the second rung. Can you explain like why is meta-analysis, at the top of the pyramid and not RCTs?
Yeah, so that's a great question. So the reason in my field is because to with science to take an individual study and assume that that's the ground truth is it can be a fool's errand. So it could be correct, but we need to replicate. Like replicating science is a huge part of science, or is it's much easier said than done. If someone conducts a $5 million trial, asking someone to replicate it just to replicate it is is a big task. But meta-analysis, in particular, taking a bunch of RCTs and combining them statistically, it really helps to paint a broader picture. Now, there's some issues like just like an RCT, a well-conducted meta-analysis is extremely useful. Um, and so when you're including different studies in a meta-analysis, you want to make sure that there are similar studies in terms of who are they targeting. Were these studies conducted? Are they well-conducted studies? Are they all well-conducted RCTs or observational studies? So it's basically that compiling of a bunch of different studies together, and here's what the result is. There's some statistical methods to do that, and then you kind of get to see what the overall result is from a bunch of different studies. Because it gets tricky if you have three studies, one says yes, there's an effect, one says no, there's not an effect, and a third says yes, there's an effect, but it's small. Which one is right? Which one is correct? So that's where meta-analyses can help out.